My name is Kenneth. I'm from MOIA, and next to me is Chris, who is also today showing you the topic of building a GraphQL subscription gateway, but in a serverless and event-driven way. So what we have come up with, or would like to show you today, is our journey of building GraphQL subscriptions on a serverless structure. So yeah, no Kubernetes, no Docker containers in this talk, but we will be rather talking about AWS Lambda, so functions that are short running. And we are also talking about event-driven architectures, which I think are very interesting. And with that, let me maybe quickly introduce you to what we are doing at MOIA. So we try to automate pooling in the cities. We are from Germany, actually, and we are trying to bring multiple people together to fulfill their mobility needs. So you can imagine if you are going into the same direction with a colleague, you are both getting into the same car, a little bit like Uber, you could imagine, and we would also like to do it autonomously. Up until next year, we would try to, also offer this mobility service autonomously in Hamburg. So a very interesting topic. You could imagine we are using GraphQL for that in order to have all our clients fulfill their needs and all the clients access the graph and all the data they want to. And today we would like to look a little bit into the subscription direction to understand also the real-time need of data. A short glimpse into how we work at MOIA. All of our teams are stream aligned, which means they have roles in their teams to build their smaller puzzle piece, means they are staffed with like backend developers, front-end developers, but also UX designers and QA. And all of them are working together to bring this puzzle piece in. And then we also have the you build it, you run it mentality. So they also care about the infrastructure, all the observability, and most of them are using GraphQL. So in the motivation, I would like to tell you a little bit about what the problems were that we faced and what motivated us in building an own GraphQL subscription gateway. We have multiple teams that are building GraphQL services, serverless in our case on AWS, but I guess you could apply our talk today also to other cloud providers like Azure or Google Cloud Platform. But in this case, they are using AWS to deploy on Lambda. So the Lambda request is behind API gateway, which is some generic service, so to say, from AWS that is handling HTTP requests. And the Lambda is only running very short. So the GraphQL request is starting, then you have the computation of your GraphQL layer, and then the response is sent back to the client. Now you can imagine this short-running Lambda isn't really suitable for WebSockets. So if you imagine the Lambda is only running for at least or at most 30 seconds, you can't really spin up a subscription here. The WebSocket server could be started, but then after 30 seconds, your client is disconnecting again, which isn't really suitable. So we needed to find a solution that is working for our teams that are building serverless in order to still fulfill their real-time needs of delivering data. And with that, we came to a few requirements and constraints that we set ourselves. So we wanted to make it easy by many teams to use this. So we are going this gateway approach. There will be many subgraphs that are talking to the same gateway to deliver their real-time data. And we want to have it a little bit easy to build. So we use the GraphQL ecosystem, libraries provided by the community, in order to make this happen. And, of course, we wanted to keep it simple. It still has to be maintained by someone, and luckily the someone is us, so we are taking care of it. And I would like to now hand over to Chris to introduce you to our products that we use or that we build and that use GraphQL.
All right. So hello from my side as well. I'm Chris, and I'm also a full-stack engineer at MOIA. I mostly work with serverless technologies, as Kenneth already mentioned. I have a focus on TypeScript and React, at the moment at least. As mentioned, at MOIA we have different products. So what you see here is, for example, a few of them. So we have a passenger app that our customers use to book their ride, so they can kind of order MOIA. Then there's the driver app, which our drivers use at the hub, at least for the non-autonomous vehicles, and manage their shifts and pick up their MOIA and kind of report accidents should they happen. And also we have a vehicle guidance app, which is basically a tablet inside the vehicles, which tells the drivers what is their mission. So what kind of pickups, drop-offs do they have, and when is the next break upcoming, or is there like a rebalancing to keep the vehicles evenly distributed in the service area. And also we have an in-vehicle screen. So this shows like the next mission of the vehicle and where it is going and where it is currently at. All these products are managed and maintained by multiple teams. And on top of those products that you see, we also have many teams working on pooling and routing algorithms, on pricing, and many, many others. But today we're not going to focus on the products you see here. We are going to have a look at the back office. So the back office application, and specifically the fleet map view of this back office is currently what was the trigger to build this product that we're talking about today. So essentially the back office is a web front end for our hub manager and operators, and it enables them basically to get a good overview of the current state of the fleet in a given service area. So they see the route of each vehicle, they see the upcoming mission and the current telemetry information of those vehicles, and also they get actively informed about issues that are happening in the field. For example, if a vehicle is out of the service area, is kind of at a stop and not fulfilling the mission, basically, then we create an alert and some operator can look into it and kind of arrange this issue to be fixed. In the end, many teams are working on this product, right? So you see here the fleet map, but there are many other kind of so-called areas which show different kind of views, and all of these components are managed by different teams, and these teams use, of course, queries and mutations of our federated graph. And now we're coming to a problem. This already, if you look into the web inspector tooling of our website, of the back office, you see already a lot of stuff is going on. So a lot of those components are constantly polling and refreshing itself to keep itself up to date. So we have 300 vehicles, and depending on where you are, this information needs to be updated all the time. And I don't know if you can see it from the back, but there are some queries that are taking like 800-900 milliseconds, and the payloads are also sometimes rather big, like talking about a few hundred kilobytes. And these are constantly refreshed, and it's first off super difficult to debug because you have your one query that you want to look into, but by the time you're trying to find it, already a lot of stuff has changed. And most of the times also the problem is identical data is returned and nothing of the payload is actually changing. So the objects can be rather big, and most of the times it's only a small change that we're interested in. So for this kind of pattern, instead of multiple polling queries, one solution is using GraphQL subscriptions. So just to get kind of an idea, please show your hands. Who's actively using subscriptions? And who's using subscriptions also with multiple teams? Like, okay, interesting, quite a few. So we will look into the protocol, but not too much. So for those that have not risen their hands, basically subscriptions is a publish-subscribe approach for small incremental changes and allows us to get low latency real-time updates. When we look at the right, you see a sequence diagram and the communication between the client, basically the web browser, and the server. And basically the subscription procedure can be grouped in 3 areas. So basically you have the connection initialization. The client kind of connects to the WebSocket endpoint, sends a connection init message, and gets an ACK back from the server. Then we have the subscription process. So the client sends the subscribe message with the payload, what it wants to subscribe to, and then from then on it receives next messages from the server, and which contain all the updates that are actually relevant. And when unsubscribing, you can either do this with a complete message, or you just disconnect the WebSocket connection. So we look at this. This is all great, but what about this in a serverless environment, right? We don't have long-running servers that can handle those connections, and we don't really have a solution for this. But luckily, we are running on AWS, and there's just a service for us. So normally we focus on mainly serverless services from AWS, so to speak, which is mostly Lambda, DynamoDB, SQS, but also RDS sometimes. and yeah, kind of use them as building blocks for our software that we build. In general, we have a tendency to outsource server implementation and focus on solving business problems instead and trying to kind of, yeah, focus on building new features for our product. So the idea is also then, why not outsource this connection handling as well? So in that case, luckily API Gateway version 2 has a feature that allows us to handle all these persistent WebSocket connections. And what happens basically is, you see here you have a client. That client talks not to one of our services, but to AWS services, the API Gateway. And there are 3 events that can happen. So one of them is a new connection. So a new client connects to a WebSocket endpoint. Another one is disconnect, which happens when a client disconnects from the WebSocket connection. And another one is default, which basically happens on every message that the client sends to API Gateway, that the client sends toward the API, yeah, to our service basically. And we can configure invocations of a Lambda in our infrastructure, and we get basically API Gateway invocations for each of these different events. So yeah, that's really useful. Additionally, we also get a unique client ID for each client that we have, that is subscribed, and can use that to send messages the other way around. So can use an API of API Gateway to actively send messages to our clients. And that leads us already to kind of a very, very high-level approach of, or description of our architecture. So you see here in green is basically our solution. You have this so-called subscription gateway, which is a shared infrastructure that is provided by us, or essentially a small team. And then you have multiple subgraph services at the very top. And these subgraph services can send updates to the subscription gateway. And based on what is contained in these updates, these get distributed to different clients from us based on the subscription that they have. So basically it's a message dispatcher, you could say. The gateway makes sure that each update gets sent to the correct subscriber. The core messages, the core services we use is, of course, API Gateway, AWS Lambda, and SQS for handling all the messaging. Additionally, we use DynamoDB basically as a cache to store the connection information, but also schema and all these kind of information that we need. Based on this, we have identified a few steps or use cases. One of them is basically, this is you see here. So basically the first one consists of a subgraph service wants to publish a schema, right? So it needs to contribute its part of the subscription schema to some registry. Then we have updating the schema from the subscription gateway, because the subscription gateway always needs to know what is the composed schema, what is available from each subgraph. And then we have the registration of active subscriptions, which is basically recording new subscribers and their subscriptions, including its parameters. And we have then the outgoing way, right? Publishing events to those subscribers, and also a more advanced use case, parameterized updates, because not every update is relevant for all subscribers. So we are now going to look into each of these kind of use cases that might look a bit confusing, but we will dive a bit into depth for each of these. So let me advance to the next slide. What you see here is basically our example subscription. It's a weather API, and it pushes weather updates to the users. So we have an optional parameter, which consists of a city. You can also leave that out, and then you would probably receive all the updates. But if you're only interested in one specific city, you can also kind of limit that with this parameter. And what you get is always weather updates, which consists of the city, the temperature, and some humidity. So essentially, one subgraph could push that schema to the registry, and from then on, it is available. It is available after the subgraph update has updated it, right? So the subscription gateway does not really know about the schema until it has updated it. So in that case, at the moment, so just for simplification, we have here like a 5-minute update that is performed by a Lambda, but it could also be triggered by another mechanism, like, for example, an API or a command that is sent over SQS or whatnot. And this schema is basically stored in DynamoDB, and from then on, it is available and can be used in the gateway. In the next step, we have recording active subscriptions. So subscriptions are actually validated and parsed before they are recorded. So what happens is, of course, not every subscription is inherently automatically possible because there are also like permissions that, for example, are part of a JWT token, are extracted and are matched against certain, for example, directives we can use. So we have some subscriptions that should only be available if you are having a specific user right? Or you are part of some group. And in that case, we want to evaluate that and make sure that not everyone can use every subscription. And for that, we built a few custom directives that can do that. And when all these checks pass, we record the subscriber information in our DynamoDB, and from then on, have it available and know which updates, where we can direct our updates to. Also, on unsubscribe or disconnect, they get removed from the database, and they are not subscribed anymore. Hand over to Kenneth.
Thank you, Chris. So maybe let's recap real quick what we have now in our DynamoDB, our database. So we have all the active subscribers, right? All the clients told us what they would like to know about. Then we have the schema. So all the subgraphs have published to the registry, and our subscription gateway has pulled the schema so we know which subgraph can tell about what. But now we need to talk about publishing updates. So we know where we would like to send updates and what we'll be sending, but we don't know what we will send. Here we are looking, for example, again, at the weather updates. This could be anything, right? We just chose one that is very graspable, but you could also imagine in our case, it's rather telemetry data of the vehicle. So like the state of charge, the current geolocation of the vehicle, anything that is relevant and that you have seen on our map, for example, all those data could come through a GraphQL subscription and are published by the subgraphs. So they are sending a custom message. We basically came up with a small contract that they have to adhere to, that we will look at in a second. And then we use the GraphQL JS library to execute and match those subscriptions, the subgraph update and the schema together to send them updates. So let's look into the details of that. Here on the left, we can see our custom payload. They are sending it to our SQS queue. The SQS queue, maybe I go back a second, we can see it here on the lower right. The SQS queue is basically a queuing mechanism that you could compare to MQTT, for example. So messages get into this queue and can be picked up by a Lambda. The Lambda is then basically a small container that is running code that is only very short-lived, as I already mentioned in the beginning. So now let's look again at the payload. Here on the left, we can see a payload. In this case, it's JSON. It could also be, in your case, maybe some other kind of language. But JSON is very graspable, so we choose that as well. In the beginning, we see the subscription name. So we are talking about weather updates. If you have a subscription about like the geolocation, for example, this would be then also written here. In the next block, we have the weather update itself. So one of the subgraphs anywhere on your infrastructure has determined, okay, the weather has changed, the forecast has changed, and they are sending us a new update to the gateway. Here on the right, you can see the code that is then executed. I mentioned we have the subscriptions, the schema, and now also the subgraph update, and all of them get fed into this function. So we can see the subgraph update, which is basically the JSON on the left, and the subscription of a client. So this function is basically called in a loop for every subscription that we have and every subgraph update that we see. We will then parse the subgraph update, basically JSON parse. And then we use the execute function, which is provided by the GraphQL JS library and is doing all the heavy lifting and basically the magic. We were kind of surprised that it is that easy because, well, building your own subgraph or your own subscription gateway sounds a little bit more intricate than it actually turned out to be, because the execute function is doing the magic. It's taking the subgraph update, like basically the data that we see on the left, and it is taking the subscription, so the GraphQL query language data, and our schema, and is doing all the matching, the magic that you already know, right? Removing fields of the data that we didn't request, and only sending the client what we need. So the result of this function is an execution result that will be returned, and we can then send back to the API gateway. Chris told you about it. It's a two-way gateway. and the subgraph can, or the subscription gateway can send a subgraph update or a response to it, also via the API gateway. So with that, we have our payload and what we do with it. But now let's talk about parameterized updates, because subscriptions can not only have one body, but they can also take parameters. We described a little distributed architecture, right? There is the subscription gateway, which is one component, and then there are multiple subgraphs in our company that are sending updates. So maybe some of them are also taking parameters. In this case, we have extended the weather updates with a city, in this case Berlin, and the subgraph update that you can see on the bottom, so the custom contract, is now also including the city, and our gateway is basically doing an equal match. So if the city of the payload matches with the city that the user subscribed to, it's an easy going, right? We see it here on the right image. Users who like to see updates for Hamburg can only get the Hamburg updates, and users that didn't specify this parameter will just get all updates. All right, then we are also close to done, but I would like to hand over to Chris again.
Thank you. We have some lessons that we learned. So by building this solution, there are a few things. So one of them is like start with something simple. It kind of looks obvious, but before actually implementing this, we were thinking about a lot of potential use cases that users might need. And in the end, it was like a mountain of requirements, and we were kind of scared and said, oh yeah, this is a lot of stuff, but it takes us ages to do it. And yeah, instead, what we said was, okay, no, we're only going to focus on some few simple use cases and not on everything that might be potentially needed. So we can always extend it and add more logic at some point in the future. So focus on something simple, and yeah, that's basically our important learning from this. Also, another one was don't try to reinvent the wheel and use existing tools at your disposal, right? So in that case, serverless really helped us, and we could combine the different building blocks that we have at our availability to create an event-driven architecture, rather simple. And also, as Kenneth already mentioned, GraphQL.js was a lifesaver because we didn't have to parse, validate, or execute requests on our own. We could just outsource it to the library and didn't really have to do any heavy lifting. Also, since going live, actually, we have added a few features. So, for example, our subscription gateway is also sending domain events to subgraph services for existing subscriptions or unsubscriptions. That allows those subgraph services to record those active subscribers and send updates out only if someone is actively subscribed. So that way, we would not kind of send useless messages that are not relevant to anyone. And yeah. So only send if necessary. And another thing we added was custom directives. So we have one custom directive, for example, to check for existing user permissions. So we can connect basically certain subscriptions with a user right that needs to be present in the JWT. And another one is verifying tenant access. So some subscriptions might only be available to certain tenants and not to everyone else. Let's have a look. We hope you found our journey into subscriptions interesting until now. Do you have any questions about specificities or stuff, how we solved something? So in general, I would say the two-digit milliseconds. We didn't really measure it, but as we are running in AWS anyway, anyway, also an HTTP request would have probably already have like a relatively similar response time. So yeah. It's kind of the advantage of being in AWS.
Do you guys evaluate server-side events at all instead of WebSockets?
No, we didn't. No. We basically, it was it was basically the feature that we had used for some previous solutions. We had a lot of experience, and WebSocket basically is rather easy to use in the Apollo client. So yeah, that's what we focused on.
Okay,
but it also has the same problem of like the Lambda can only run for this set amount of time. So API Gateway is currently by default constraining us to 30 seconds. So you could make this long-running HTTP connection up until 30 seconds, and then you have to resubscribe. So that was the problem that we wanted to fight. Nowadays, actually, API Gateway has, I think, gone up to 10 minutes. So you could get around that and then have a resubscribe after 10 minutes. Could definitely work as well, yeah. I can take it. So you can imagine like the fleet map that we showed. It is sending updates for the vehicles like every 4 seconds, I think. So if you scale it up to like 300 vehicles, sending location updates every 4 seconds, this is already what we can handle. I don't know the sum of it, but something like that is easily handleable. And of course, there's also still room to improvement. For example, we now chose SQS, which is good for medium to large amount of messages, but you could even scale more if you choose technologies like Kinesis, for example, which is better at high throughput, and we are not really limited here. So theoretically, you could scale this up very, very large. That's the benefit of going serverless. So we don't really have to care about, okay, will this ever be hitting a limit that we can't fulfill?
You are referring to those 3 events, right? So essentially, those events are only emitted at the beginning, at the very beginning of the connection, and at the very end, and then for each message that we get. So it's not related to kind of API gateway invocation. It's basically like API gateway handles all the connection for us. So it abstracts with events for this for us. So yeah. This is basically this is standard functionality from API gateway. So it's nothing like we built, but API gateway has these 3 kinds of invocations. So let's assume you have a WebSocket endpoint provided by API gateway, and you have a new client connecting, and then we would get like 1 invocation of our connect lambda. And then each time, and that's it, right? And that connection, that invocation runs as long as that connect lambda is alive. So probably not very long, so just a quick connection to DynamoDB and then storing the subscriber data. And then for every message that the client would send to us, we would get another invocation of another lambda that we could specify and then do the handling there. And then additionally to this, we would get 1 more invocation for the disconnect. And that would call our lambda, which would then remove the entry from DynamoDB for the current subscriber. So it's basically events that we get, so to speak. It's a bit difficult to see here, but yeah.
So the subscription gateway is something that we built, right? We took all the building blocks that we found and like established this architecture we can see here on the right, consisting of the different AWS services, basically.
Okay. So, sorry, one more follow-up question. So,
sure.
how do you manage scaling on this API gate? So, for example, if you are doing horizontal scaling, do you see any challenges regarding managing the connections?
That's the good part of AWS and serverless. They are taking care of that. Yeah. We don't have to, like, we have not run some TÜG gateway or something like that, a container that is taking all these WebSocket connections, but we basically told AWS, hey, we would like to have a WebSocket server, can you deal with that? And then they will manage all the connections, they will manage the scaling and will take care that the clients don't disconnect or that they can reconnect and that it's available 24/7 and we don't really have to care about the maintenance or observability of that specific service. They are basically providing us with the building blocks and we have taken all these building blocks to build a better picture out of it that can serve GraphQL subscriptions.
Yeah.
You're welcome. Okay, then we are over time already. Thanks a lot.